Thin layer chromatography, or TLC, is a chromatography technique used to separate mixtures into their individual pure components. It involves a stationary phase consisting of a thin layer of absorbent material, in this case silica gel, which is layered on a flat inert carrier sheet of plastic. A liquid or mobile phase consisting of the solution to be separated is then dissolved in an appropriate solvent and is drawn up the plate via capillary action, separating the components in the experimental solution based on the polarity of those components in that solution. When one end of the chromatogram sheet is placed in an appropriate solvent reservoir, in this case a mixture of water, butanol, and acetic acid, capillary action draws the solvent front from the reservoir of solvent to a point at some distance from that reservoir. The motion you see here was from bottom to top, but we turned the camcorder on its side so that we could capture a greater length of movement, so you see it going from left to right. Here we're separating the pure substances which make up the colors contained in the ink of felt-tipped pens. In chromatography, one speaks of the rate fraction, or RF, of each substance, the ratio of the distance moved by a substance divided by the distance of the solvent front. Note first of all that 12 felt-tipped pens were used to put evenly spaced spots about 1 centimeter from the left edge of the chromatogram. The movement of each pure substance depends on how strongly it binds to the silica gel in competition with how strongly it binds to the solvent molecules. Greater relative binding to the mobile phase or solvent produces faster movement. Note first that in the beginning of growth, each felt-tipped pen spot elongates to produce a streak. Only when the streak becomes sufficiently long does one see the separation of individual chemical substances. A specific chemical substance will always move at the same rate for a given solvent, so if that substance is contained in 2 or more pens, it can be tentatively identified as the same substance. Note first of all that pen number 8 from the top was a black pen, likely composed of granular carbon black, which remains stationary on silica gel and doesn't move in the direction of the solvent front. Pens 1 and 2 from the top have a red component, which can be tentatively identified as the same substance in those 2 pens. Pens 6 and 9 also have a red substance with about the same RF as that for 1 and 2, but it isn't clear if it's the same material because of the slight differences in shapes. Pens 10 and 11 look very much like they might be pens of a certain color made in the same batch, as there is a pair of blue substances and a pair of brown substances, all of which seem to have the same RFs. Pens 6 and 9 have red spots with high RFs and red spots of medium RFs, but the elongation of the medium RF red spot in 6 isn't repeated in 9. The medium RF spot in 9 is a much better defined region on the chromatogram. Although pens 1 and 2 produce similar spots with a high RF, there's a blue fraction in 2, which suggests that the 2 pens contain different mixtures of inks. Likewise, pens 3 and 4 both have strong blue colors with medium to low RFs, but pen 4's blue color is more greatly elongated than that of pen 3, suggesting that they are different substances. Pen 5 has several blue-green substances and a yellow substance in it. This combination is not repeated by any of the other pens. Pens 7 and 12 also have patterns which are not repeated elsewhere in the chromatogram.